to, I'll quickly show my PDF as well. This is my fifth program, Cohen Sutherland algorithm. And you can see in my PDF, this I have taught you now. What is top, left, bottom, right. And also I have taught you this. And I have taught you this. The same things will now come into your program. You can see all these equations are nothing but calculating intersection points. So this is how my program looks like, and yeah, we'll see all these now. All right. So go back to the code blocks. So I have my program, and if you run for your sake, yeah, let me show the output. So this is my input and this is my output. I have clipped from this point to this point, and from this intersection point to this intersection point. Can you now tell me why exactly I have zoomed this portion and I'm showing this here? The reason is, if I don't do this kind of an activity, the customer will not be, customer in the sense you will not be able to see what is input and what is output. The moment you run the program, you will only see this particular piece. So I just wanted to show what is the input and what is the output. So next question you should get is, why exactly I am zooming this? That is purely my wish. I can say I might as well, written this output next to the input itself, which you could have done it. But I thought, let me show this, in a bigger scale to my students. So that's the reason I am zooming this and showing it at the center of the screen. You need not have to zoom it like this. You can perhaps show the output here itself. Or what you can do is show the input to the customer, have a delay for 2 seconds, and then there itself you can show the output. So it depends on the customer satisfaction. If the customer wants both the input and output to be seen, perhaps you can do something like this. And if he wants the output to be shown, to be showed in a bigger scale, so you can zoom like this and show. So zooming is also, in fact, we have done this in 2D viewing. I have taught you the scaling factors, right? If you can remember, while teaching 2D, 2D transformation, 2D viewing, I had, while derivation, that big derivation, what we did in the class. So scaling factor of X is this, scaling factor of Y, all this we saw there. Anyway, so we'll come to the program now. We'll close this. Okay. So this is the program. Let us start from the main. So main this is nothing but initialize graphic system, and this is single buffering mode, and this is my RGB, red, green, blue. Single buffering mode. Why? Because no animation is required, and I'm not showing any 3D with animation or whatever. It's just 2D static image which gets clipped off. So I should not write, or I need not have to write glut_double. All right. So window size 500 by 500. My window position, initial window position, starts at 0,0. These are all purely my wish. You can purely developer's wish. You're free to change all this. So I have a window which says this heading, and let me call my init. My init is here. So I am having a black window. This one. Yeah, it's starting at 0,0, and I have a black window, and my ortho 2D, my camera coordinates is also 500, 500. So my LRBT, which I have taught you in the class, that is also 500, 500. So my window size is also 500, 500. My camera coordinates, this is LRBT, left is 0, right is 500, B is 0, top is 0. This is my viewing is L comma B. So LRBT, left, right, bottom, top. All right. So now coming to this glut display func of display. So I will go to display function and x0, y0, x1, y1. So x0, y0 is apparently this, the line starting point, and the line's ending point, that is this point, this is 80, 120. So the line starts from 60, 20 to 80, 120. So GL color buffer bit, whatever we had set the color to be black, it will now flush to my screen. And GL color 3F111 means my pixel color is white, meaning to say my primitive pixel color is white. You can see this white rectangle, white line. These are, the courtesy, this line, 115 line. So now let us concentrate on this part. Let us show the input of the customer's input. So begin lines. So vertex 2D, vertex function, GL property, 2 arguments, D is double, x0, y0. So 60, 20 is this, and x1, y1, that is 80, 120 is this line. Let me draw the line first. And then how do I draw this rectangle? Well, it is just nothing but a line loop. Line loop, x min, y min. So x min, y min, x max, y max, these are all my global coordinates. So x min is 50, 50, x min, y min, and x max, y max is 100, 100. Means to say this x min, y min, this whatever we showed here, this one, x min, x max, y min, y max. These whatever I showed now happens to be 50, 50, 100, 100. And x v min, y v min, x v max, y v max. These are my viewport candidates, viewport coordinates. So viewport coordinates in the sense these. So where exactly I'm viewing it. So these are my 200, 200, and 300, 300. I'll come back to that in a moment. So where, yeah, we are done with this. So we are done with the input line and the input clipping rectangle. And next it is our job to call Cohen Sutherland by passing the rectangle, clipping rectangle. Sorry, the line that needs to be clipped, that is x0, y0, x1, y. So go to Cohen Sutherland. So you are passing x0, y0, x1, y1. Actual parameters will now be collected into my formal parameters. Same parameters, same arguments are given, same variable names. All right. So you remember this? We talked about regions. LR. Top left, bottom right, top bottom right left, whatever sequence you prefer. So we should be carefully chalking out our plan about how exactly a pixel situates in any of these regions. So we call those as outcode regions. So we definitely have 2 outcode regions. One is outcode 0 and outcode 1. Means this particular pixel, and we can name it as outcode 0, and this is outcode 1. And the final one, the one which will allow us to decide where exactly this outcode 0 is situated, that will be pasted in, that will be held in a new variable called outcode out. We'll come back to that in a bit. So I have a Boolean variable, accept and done. So if I say accept is equal to false, means if you take this particular portion, so accept equal to false means the pixel number E is also outside, pixel number F is also outside. So both the guys I should reject it. Accept is equal to false. So if you can take A, B, both the guys are falling inside the rectangle. So accept should be true. and there is done. Done is equal to false means right now the done variable is false, means we have not yet started our algorithm. The moment we make done as true, that means we are done with the algorithm. You will understand that in a bit. So outcode 0, that is the first points, that is x0, y0, outcode region. So outcode region means if you take the point, the line CD, C is inside, D is outside. So C is inside, I can understand. D is outside this rectangle, a human being like me can understand. But how do I make the machine understand? I should be making my machine understand about this. I'll assign the outcode regions, the 4-bit codes. So something like this. So outcode 0, that is calculating the region of first point. You call this function outcode 0 of x0, y0. So go to this function, compute outcode of x0, y0. That is apparently this, compute outcode x0, y0. So where exactly your point lies. So initially make your code as 0, the initial code variable. 0, understand 0 means here. This is 0 means everything is inside. So let me assume that everything is inside. So once I assume it, then I'll calculate the exact point, exact region. So if y, what is y now? You're sending x0, y0. So y is apparently y0 now. If y0 greater than y max. So what is your y0? So I am passing from Cohen Sutherland. So from Cohen Sutherland, I am calling compute outcode x0, y0. So x0, y0 is your 50, 50. So the same things x and y is also, in this case, it is 50, 50. So what is y? Y is 50 now. 50 greater than y max. What is y max? 100. So is 50 greater than 100? No. 50 is not greater than 100. Else is 50 less than, what is y min? Y min is 50. Is 50 less than 50? No, 50 is not less than 50. 50 is equal to 50. So the control doesn't go here. Next one. What is x? X is 50. 50 greater than, what is x max? X max happens to be 100. Is 50 greater than 100? No, the control doesn't go here. So next one, else it checks, is x 50 less than, what is x min? X min is 50. So 50 is less than 50. No, 50 is equal to 50. So control does not go here. Control didn't go here, control didn't go here, it didn't go here, it didn't go here. You can ask me why, or what is the logic behind this. A return code means to say x0, y0 is this point, the x0, y0. A return code means it is 50. So return code. So code will now be returned as code equal to. So just to cross check again. So you're passing x0, y0. Where are my x0, y0? Oh dear Lord, it is 60, 20 guys. Sorry. It is 60, 20. I'm so sorry. This is 60. This is 20. Y. It is 60. Sorry, y is 20. X, it is 60. My mistake. All right. So now let us, x0, y0 is 60, 20. Now I'll pass 60, 20 here. All right. So 60, 20 will be passed. Y 20 greater than 100, no. 20 less than 50, yes. The control will now go inside this. So 20 less than 50, Y is 20, Y min is 50. So 20 less than 50 means yes, control will now go inside this. Now this is fine, mathematics is fine, but I would like to let you know from the logic angle as well. Why exactly control went here? The logic behind that is, see, where is x naught, y naught is here. It is where? Bottom, left or top or right? It is at the bottom. We human beings, we know that this is at the bottom, but how exactly I can make my machine understand? This is how I can make my machine understand. So basically you have all this and check your outcode regions. So in these 4 loops, the control will go inside. One loop will satisfy. So 20 less than 50, code or is equal to code or bottom. So code will now become, so this is equal to code or bottom, which will now be, what is code? Initial 0000, or what is bottom? 4. So 4 in the sense 0100, which if you OR these two, you will get 0100. So this is my latest code now. Code is equal to code or bottom 0000 or 0100. So this is 0100. So what is understanding? So if I send 60, 20, I know that this is at the bottom, and I made my machine understand something like this. So code is now 0100 means that is nothing but, what is 0100? It is 4. But what is 4? 4 is bottom. So we understood that this particular point is at bottom. So let us also, yeah, if I go with this, the control doesn't even, the control after this, it will go here, because this is, and this is just if, this is not else if. Had I written here else, control wouldn't have gone inside any of this. So don't write else for this. I should check my y, I'm done with my x. I should be now checking for x. So what is x? X is 60. 60 greater than 100? No. Else is 60 less than 50? No. So it doesn't go here. Return code. So what is the code now? So the calculated code is 4. So I'll return 4. So what is the meaning? The meaning is x naught, y naught. That is x naught, y naught is lying bottom. So why bottom? Because 4 is bottom. Now, so outcode 0, because this guy will now return, it will now return 4, and 4 will be now placed in this outcode 0. Similarly, we'll calculate outcode 1. You will now understand if you have any doubts here. x1, y1, what is x1, y1? Let us not make that mistake. 80, 120. So 80, 120. Can you now tell me what exactly this function will now return? Outcode 1. So 80, 120 is here. It is where? At the top. So top meaning to say 8. So that is what this function should return. Let us see whether it returns. So x1, y1 is 80, 120. So this is 80. This is 120 now. All right. So code is 0. Is y. Y is 120. 120 greater than y max is 100. Yes. 120 greater than 100. Yes. Code will now become code equal to code or top, which is equal, what is code? It is 0. So it is 0000 or with top. What is top? Top is 8. So 8 is 1000. So which is, if you OR 0 with 8, you will get 1000, which is nothing but 8, which is nothing but top. So 8 means it is top. Yeah, common sense. 80, 120, this is situated at top region. For example, if I take a horizontal line, something like this, so you will understand that this is at the left portion and this is at the right portion. So since we have taken a vertical line, so we understood that the x0, y0 is at the bottom, x1, y1 is at the top. So we should make the machine understand about this. So similarly, we'll check if y is greater than y max. Since the control is satisfied here, control will never go here. And since this is just if, so it will check, it will go here. It will just check what is x. X is 80, greater than 100, no. And since I have not satisfied here, I'll check here. What is x? X is 80, less than x. X means no. So return code. What is code? Code is 8. So return this 8. Meaning x1, y1 is at top. Alright. So this guy will now return 8, meaning it is now at the top. So outcode 0 is 4, outcode 1 is 8. That is, this is outcode 0. This is bottom 4 and outcode 1. This is at 8, means it is at the top. Alright. So it's a do while. Now we will see what needs to be accepted, what needs to be rejected, and all these mathematics. Alright. Now now the if loop says if outcode 0 or outcode 1. So means to say if not equal to outcode 0 is 4 or outcode 1, that is 8. So nothing, which is nothing but what is 4 or 8 is 0, 1, 0, 0 or with 8. This is 8, which is nothing but 1, 1, 0, 0. Right? So which is nothing but 12 in decimal. I mean, the 1100 is 12, which is nothing but true. Now what he says, not equal to true, means it is false. So it becomes something like this. It will now get calculated as if not equal to or true, which will now translate to false. So if false means the control will not go here. It will now come here. Now it says if outcode 0, that is 4, ampersand outcode 1, that is 8. So what is 4, 0, 1, 0, 0, ampersand with 8, that is 1, 0, 0. So if you add these two, you will definitely get 0, 0, 0, 0, which is equal to 0, which is equal to false. Now what he says, if false. So I will not go to this line, because it says else if this is false. Yeah, we got to know that this is false. If false, if true means I would have gone here. Because it is if false, control doesn't go here. It comes to this else part. Now here comes the Cohen-Sutherland mathematics. So double x comma y, okay. Now we know the slope. It is y1 minus y0 by x1 minus x0. Now what is outcode out? Okay. Now what he says, if this is true, outcode out will now hold outcode 0, else outcode 1. So what is outcode 0? Outcode 0 is 4. That is true. Outcode 0. It translates something like this. Is 4 question mark. outcode 0 is 4, colon, outcode 1 is 8. So what he says, if true, if that is true, select 4 or select 8. This is the conditional operator which you have studied in first or second semester PCD. So yeah, now outcode 0 is 4, which is true. So I will select outcode 0 and I will put this outcode 0 to outcode out. So your outcode out will now become outcode 0, that is 4. So outcode out is now 4. Now comes to this. If outcode out, that is 4 and top, what is top? Top is 8. So 4 and 8 means to say 0 1 0 0 ampersand 1 0 0, which is equal to 0 0 0 0, which is equal to false. So if false, so I will not go inside. Next one, outcode out, that is 4 ampersand bottom. What is bottom? Bottom is 4. So outcode out 4 and bottom is 4, which is equal to 0 1 0 0 ampersand 0 1 0 0, which is equal to 0 1 0 0, which is equal to 2. Yeah. So 4 and 4 is 4 and it is true value. The control will now go to this part. But the real mathematics, the real fun starts here. You remember we did all this? All right. So if my outcode is at the bottom, means here. Yes. If my outcode is at the bottom, y is equal to y min, x is equal to this. Whatever we discussed a couple of minutes back, we will apply this form. Simple. So before that, it is what? X is equal to x naught plus 1 by m times y min minus y naught. That is 4. Yeah, this is 4. So outcode out is 4 equal to outcode 0. What is outcode 0? Outcode 0. This is 4. So is 4 equal to 4? Yes. Go inside. X naught is equal to x. So what is x? X is now 66. So this guy is 66. Y naught is equal to y. Y is now 50. So I am just earmarking my x naught comma y naught. Can you now tell me why am I writing or making xy as x naught y naught? What was my x naught y naught past tense? It was 60, 20. Right? It was 60, 20. Now what is x naught y naught? 66, 50. So I'm just earmarking that this is my first point now. That is, this is my starting point now. It was, starting point was 60, 20. Now the starting point is 66, 50. Now we'll again calculate outcode 0 because who knows, a single pixel can be outside. So we'll again calculate this. So we will now pass this 66, 50, 66, 50 as my x naught y naught. So it is now 66, 50. So code is 0. You will now understand that everything is 0, 0, 0. That is what I was talking about earlier. So what is y? Y is 50. 50 greater than y max. 100, no. Else part I'll not check, but for your purpose I can write y is 50, 50 less than 50, no. X is 66, 66 greater than 100, no. Else part it will not check, but anyway we shall write 66 less than 50, also no. So code, the control is neither going here, nor here, nor here, nor here. So control will now go here, return code. What is code? Code is 0. What is code is 0? Meaning your x, because you are passing x naught, y naught, the latest x naught, y naught. X naught, y naught is lying where? Code is equal to, see guys, 1 means left, 2 means right, 4 means bottom, 8 means top, but we got 0. What is the meaning of 0? Meaning of 0. Yeah, here. Meaning 0 means the pixel is inside the window. In fact, we had got this as bottom, now we got this as 0. So, is lying inside the window. Alright. So, return this 0. Where will you collect? You will collect this to outcode 0. So, my outcode 0 is now 0. Because complete outcode, it is returning me 0. Return code. So, my outcode 0 is 0. Since I am done with if loop, I will not check else part. So, you should keep on doing this as long as this guy is true. What he says now, he says not equal to, what is done? Done is, we didn't go inside this, we didn't go inside this. So done remains, it was false, it is still not equal to false, means it is not, not equal to false means, of course it is true. Not equal to true means false, not equal to false means true. So while true, yes, go inside the do loop. Now, what is outcode 0 now? Outcode 0, I have calculated this as my 0. So outcode 0 is 0. Outcode 1 remains same.
You can hear, no?
We didn't touch outcode 1. So 0, 0 or with 8. 0, 0 or with 8 means this is 8. This is true. Not equal to true means false. So if false means control will not go here, control will now come here. If outcode 0, that is 0 and 8. So this is 0 now, and 8 is equal to 0, is equal to 0, is equal to false. If false, so don't go here. Come inside. Double xy m. M will now again change. Why? Because x naught, y naught have been changed. You can see here. X naught is 66, y naught is 50. So we'll do that. Y1. What is Y1? X1, Y1 we didn't touch. X1, Y1 we didn't touch. We only touched X naught, Y naught. So 66, 50. So Y1 is remains same. Y naught, that is 66, 50. So this guy will now become 50. And X1 remains same. X naught, it was 60, it is now 66. So can you now tell me 120 minus 50, this is 70 divided by 80 minus 16. it is 14. So 70 by 14, it is 5. All right. If now comes this, outcode out is equal to outcode 0. My outcode 0 is 0. So I will say outcode 0 is 0 question mark. It is outcode 0 is 0. Outcode 1 is 8. So now guys, look here. This is the interesting part. 0 question mark 0 colon 8 means if 0 is false, you can either, it says if false means don't take this value, take this value. Means if this is false, don't take this, take outcode 1. So the condition becomes like this. If 0, this you can take it as true case, this you can take it as false case. So since this is false, this you will not be taken, this will be taken. So outcode out will now be outcode 1. Outcode 1 is 8. 8 will now be given to outcode out. So outcode out will now become 8. What do you mean by outcode out is equal to 8 is we are now looking at the top region. That means we are now looking at this guy. All we did, all these mathematics, whatever we did, this happened for the first point, x0, y0. Now we have to do the same mathematics for x1, y1. So the outcode, outcode is now 8. Now check. Outcode out is now 8. Is 8 ampersand top. Top is anyway 8. So outcode out 8 and 8, that is 100 ampersand 8. This is 100. This is now true. So 8 and 8, you will get 8, and that is true. So true and true, it is true. That means you are in the top region. Remember last point, x0, y0, we went inside this. Why? Because x0, y0 was at the bottom. Now x1, y1 is at the top. That is the reason we are going inside this. 8 and 8 is true. So go inside. So now comes the the mathematics. X is equal to x0. What is x0? 66. So 66 plus 1 by m. M is 5 times y max. What is y max? 100. Is 100 minus y0. Y0 is being changed here. It is 50. So so please calculate. So 1 by 5, 100 minus 50 is 50. 50 by 5 is 10 plus 66. It is 76. Right. So what is y max? Y max is 100. So it is 100. Okay. If you ask me what are these formulae, well, you remember this. If you lie at the top, so y is equal to y max. That is what we did here. Y is equal to y max. And x is equal to x0 plus 1 by m times y max minus y0. This is what we did. X0 plus 1 by m times y max minus y0. So this is my x. So this is my x. So 76, 100. Now what did we understand? X and Y is 76, 100. The if loop has been satisfied here. I will not go to this cells. I will not go to this cells. I will not go to this cells. I will check whether here, what is outcode out? Outcode out. It is 8. 8 equal to outcode 0. Outcode 0 is 0. Right? Outcode 0 is 0. So 8 equal to 0, it is no. So control will not go here. Control will now come to this. Can you now understand what's the logic? Because if the control had gone here, that means I am done. I would have taken care of X naught, Y naught. Since the control is now has gone to this part, it means I now should take care about X1, Y1, which is nothing but this. This is X naught, Y naught. This is X1, Y1. We made this intersection point as X naught, Y naught now, and we have X1, Y1. The intersection point as 76, 100. We will now make that X1, Y1 as 76, 100. Something like this. So X1 is X now. So what is X? What is X? Here. 76. Make that as X1. Y1. Y1 as my Y. So Y is 100. So make this as 100. So now we'll calculate whether we have perfectly calculated the outcode region of 76, 100. So we will now pass 76, 100. What it will return? It should return 0, because 0 means inside. 0 means it should return 0. We'll see whether it returns 0 or not. So I'll write this in a moment. So 76, 100. X1, Y1, 76, 100. We will pass outcode out, compute outcode. So this is 76. This is 100. Now code is 0. Fine. Y. Y is XY. This is 100. Is 100 greater than 100? No. I will not go to else, but anyway, I will write here. Y is 100. 100 less than 50? No. X is 76. 76 greater than 100? No. Anyway, we'll write X, this loop as well. 76 less than 50? No. So control neither went here, nor here, nor here, nor here. Return code. Whatever is the code is 0. Return code. Code 0 meaning X1, Y1 is lying inside the window. So return code, return 0. You can see the return type as integer. So it will now return 0, and that 0 will now be taken to outcode 1. So outcode, the final outcode 1 is now also 0. Now comes to these flower brackets. Now comes to this not equal to, as you remember, we didn't go inside this, we went here. So we didn't touch my done guys. So the done remains false. So not equal to false, true, while true. Yes, go inside the do loop. Now we will see the magic. Outcode 0. Both outcode 0 and outcode 1 are. Outcode 0 is also 0. Outcode 1 is also 0. So 0 or 0. 2. 0 or 0. 0 or 0 is 0. 0 means false. If not equal to false. Not equal to false means true. So if not equal to false, if true means, what do you do? Accept, make it as true. Done, make it as true. So the moment done became true, this guy will now check. While done is true now. That means what? Not equal to true means false. The control will now come directly from this point, because this is a leaving situation where we should leave here as long as done is false. Now that done became true, I will directly come to this point. Now except is also true now in our case, because we went here, except is true, done is true. So done became true, we came out of the loop, and except is also true. So now go here, if except, that means if true, except became true. And this is, anyway, I have taught you in the 2D viewing class. These are my scaling factors, means to say this, the zoomed there, scaling one. I taught you in the class what is positive scaling, negative scaling. Positive scaling means the same shape getting increased. Negative scaling means the same shape getting reduced. Now since we are having positive, so we will take positive scaling factors. This I have taught you in my theory class, just to give you an idea. You remember this? Yeah. So yeah, if you remember all this, whatever we did this big derivation, right? So all this derivation and the problem. So yeah, go back to that. This problem, xv is equal to xv min plus this into sx, and that is what this sx stands for. So yeah, here. I'm saying this sx is equal to xv max minus xv min by xw max minus xw min. So that is what he says. And sy is yv max minus y minus, sorry, this is yv min. Yeah, this should be y, sorry, w max minus yw. That is what this guy says. And vxy, my viewpoints. So do the same mathematics, you will get this. So apparently in fifth program, this, whatever derivation we did, all this, these are the equations here. All right. So write those equations. We can calculate. I request rather you guys to calculate. I'll show one guy. Sx, what is xv max? Xv max is 300. So we'll write. Please open up your calculator. So it is 300 minus xv min. It is 200. 300 minus 200 divided by x max minus x min. So what is x max? X max, not xv max. X max is 100, x min is 50. So 100 minus 50, which is equal to 100 by 50. It is 2. This is 100 by 50. All right. Each guy gets 2 rupees. Similarly, do for sy, vx0, vy0, vx1, vy1. You will get these guys. This is your window. This is your view window. This is x min, x max, y min, y max. This is your vx0. Vx0 is this guy. Vy0. This is vx1, vy1. Calculate these. You will get the zoomed version of this. That means you have the 66, 50 and 76, 100. The zoomed version of 66, 50 can be something like 86, 60 or whatever. The zoomed version of 76, 100 can be something like 96, 120, whatever. So those values you will get for these guys. Vx0, Vy0. I'll tell you what do you mean by Vx0. See, x0, y0 is your input. Vx0, Vy0 is this output's first angle, first coordinate. X1, Y1 is your input here. and Vx1 Vy1 is your viewport x1 y1. So once you get Vx0 Vy0 and Vx1 Vy1, mind you, Vx0 formula, in that formula you should apply this Sx, the calculated one, and Vy0, Vx1 Vy1. So what I ultimately want is Vx0 Vy0 Vx1 Vy1. So once I am done with that, and now my job is very simple. I'll draw one line loop, one rectangle. Now rectangle has 4 points. I'll write that xv min, yv min, xv max, yv max, I mean all these points. So I'll get this big rectangle. Now I should draw from Vx0 Vy0 to Vx1 Vy1. So draw the line Vx0 Vy1, Vy0 Vx1 Vy1. End it. So once you're done with the entire Cohen Sutherland, you come back to this and you flush it. Now this essentially ends the discussion, but we will close the loop by keeping last 5 minutes discussion by keeping breakpoint. So what we will do is so where we started the line, display, if this is the input in Cohen Sutherland, we will go and yeah, this is cut. Now what we will do is first I'll show you this way. First I'll keep the breakpoint here, and let me close all this. All right, so blood display, funk of display. I'll come to display. I'll breakpoint is here. So debug it. Compiler is in use. Yeah. So display, yeah, we'll keep it. The flush, debug it. So it will now go to the debugging mode, and I kept my watch. It's not Y0, X1, Y1, all those. So the yellow triangle is here. That means to say the control is here. So what we will do is we'll say next line. So I got this line now. So we'll now click next line. Flush it. We'll get a flipping rectangle. Now don't press next line. You should apparently go to Cohen Sutherland function. So press step into, So yeah, step into, you can see all my regions. So now you can say next line, all this. It will now calculate all those whatever we did. So yeah, ultimately it comes, calculates all my output zeros, whatever we did, whatever we tried to do manually. And yeah, and then it became done. So SX naught, now I can press next line. SX naught, SV naught, VX naught, yeah. Line loop, I'll get a maximized rectangle, correct? So now my job is to give me a nice line, something like this. So that's it. That's it about today's session. I hope you really enjoyed it. I will, of course, the recorded video I'll post to YouTube. Let me know how the session went in my YouTube comments, and any doubts, please post there itself. Thank you. Thanks for your time. Thank you.